Hello viewer, welcome to Samuel Academy. My name is Samuel. In this video, I want to discuss about errors and approximations. Let us start by looking at a problem. Round off 267.539 correct to 2 decimal places and find the error. 267.539. If we round off to 2 decimal places, we get 267.54. Alright, now we are supposed to find the error. To find the error, what you do is that you take the actual value, subtract the approximate value. In this particular case, the actual value is 267.539 and the approximate value is 267.54. So when you get the difference between the two, we get 0.001. That is the error, right? But what are these? Okay, what are these? Now, we find that this refers to the modulus of 0.001. Alright? Now, we realize that this number is smaller than this number. So we are going to get a negative value, but you don't see it here. We have taken only the positive value, which we call the modulus of 0.001. Let's discuss something about the modulus. The modulus of x. This is how we write the modulus of x. Alright? It means the size of x regardless of the sign. The size of x irrespective of the sign, whether positive or negative. Okay? So it is written by using this symbol, the modulus of x. Now the modulus of x is defined by the modulus function formula, which says that fx is equal to the modulus of x, okay, such that x is positive if x is more than or equal to 0, and x is negative if x is less than 0. Okay, so in this case, you write it that way and you disregard the sign. So this formula gives the non-negative values of x, which we call the modulus of x. Now let's see how we can get the absolute error and the percentage error. Absolute error is equal to the maximum value of whatever quantity, subtract the minimum value, then the answer you divide by 2. Let's look at an example. A rectangle is measured to the nearest centimeter. Find the absolute error in the area. Find also the percentage error. So this is the rectangle, whose length is 12 centimeters and width it 10 centimeters. So to find the absolute error, we must find the maximum value and also the minimum value. So in this case, the maximum value is the maximum area. For us to get the maximum area, we must find the maximum length and also the maximum width. So the maximum possible length here is 12.5 centimeters, because you have been told that this rectangle is measured to the nearest centimeter. So that 1 centimeter divided by 2, you get 0.5. So the maximum value of the length here is 12.5, and the minimum value is 11.5, right? And for the width, the maximum value is 10.5, and the minimum value is 9.5. So to get the maximum area, you multiply the maximum length by the maximum width, which is 12.5 times 10.5, you get 131.25 square centimeters. To get the minimum area, you multiply the minimum width by the minimum length. So you get the minimum length is 11.5 times the minimum width is 9.5, you get 109.25 square centimeters. So the absolute error is equal to the maximum value, the maximum area, minus the minimum area, then the answer divided by 2, which is 131.25 minus 109.25 divided by 2, you get 11 square centimeters. All right? So the percentage error is equal to, in this case, the absolute error divided by the actual value. This is the formula for getting the percentage error, then times 100. The absolute error is 11. The actual value of the area here is 10 times 1 times 12. You get 120 square centimeters. So 11 square centimeters divided by 120 square centimeters times 100, you get 9.167%, correct to 3 decimal places. All right? Ignore this one here. So that is the percentage error, which is obtained by dividing the absolute error, we divide by the actual value of that quantity times 100. That's how we find the absolute error and the percentage error. Let's look at this problem. Given that x is more than or equal to 6 and x is less than or equal to 8, and y is more than or equal to 2 and y is less than or equal to 5. Find the range within which x plus y out of x minus y lies. So in this case, we need to find the maximum value of this expression and also the minimum value. How do you get the maximum value? To get the maximum value of this expression, the numerator must be greater, must be maximum, the maximum possible numerator here, divided by the minimum possible denominator here, you will get the maximum value of this expression. So the maximum value of this, you take the maximum value of x, which is 8, plus y, where y is the maximum value here, which is 5. 8 plus 5, okay, divided by, here we have to get the lowest value of the denominator. So you take the lowest value of x, which is 6, minus the highest value of y to get a very small denominator. So 6 minus 5 is 1. So you get 13 over 1, which is 13, the maximum value of this expression. Let's find the minimum value. To get the minimum value of this expression, you must find the smallest numerator possible, divided by the highest denominator possible. So to get the lowest numerator possible, we take the minimum value of x, which is 6, plus the minimum value of y, which is 2, okay, 6 plus 2, divided by the highest value, because this one must be big. The highest value of x, subtract the smallest value of y to get a very big denominator here, okay? So you get 8 minus 2, which is going to be 6. So that is 8 out of 6, you get 1/3. So this is the lowest value of this expression. So we find that this expression, x plus y out of x minus y, lies between 1 1/3, the minimum value, and 13, that is the highest value. So that's how we do this kind of problems. So I'm sure this video has been of great value to you. So I want to request you to subscribe to Samuel Academy on YouTube to see more videos in physics, in chemistry, in mathematics, geography, and weather. And also remember to like this video on TikTok. Thank you.